Hi everyone, in this video I'm going to take a look at an example of complex numbers. It's going to be maybe a little challenging, this one, a little challenging. So here are the complex numbers I'm going to work with. 4 take away I divided by 2 take away I, and I times z. So the first thing I'm going to do is write these in the usual format, and the form is going to be a plus bi. A and b are real numbers, and then just the usual stuff. I'm going to find the modulus, the argument, I'm going to draw them, and just some other bits and pieces. So let's say the modulus of w. Let's find the argument of w, and let's draw them. Let's just draw both of them, z and w, and just for fun, let's find the modulus of the difference. Okay, so I'm going to take a look at each of these pieces. So let's start with a clean page. Let's do part A, which is writing them in the usual form. So if z is a fraction of complex numbers, so how do we write this in the usual form? Well, you times the top and bottom by something. We want to clear this I off the bottom. The trick for this is times the top and the bottom by the conjugate of the bottom. What does conjugate mean? Well, whatever you see in front of I, just change the sign of it. Okay, so across the top, I'm going to multiply these complex numbers. And the bottom, I'm going to do the same. I'm going to multiply those two numbers. So let's start with the top. Why not? 4 times 2 is 8. 4 times I, 4i, minus I times 2, and minus I times plus I, minus I squared. The bottom, 2 times 2, 2i, take away 2i, minus I squared. Okay, so we're clearly going to need the fact that I squared is minus 1. So on the top, let's highlight it. We have this I squared. Well, this is minus 1. So actually we have 8 minus 1, which is 8 plus 1, which is 9. And in the middle, we have 4i take away 2i, which is 2i. That fixes the top. How about the bottom? Well, the 2i and the minus 2i cancel. We have this I squared is minus 1. So we have minus 1, it's plus 1 on the end. We have 4 on the beginning, so this is 5. Giving the final answer of 9 over 5 plus 2 over 5 times I. Just to be clear here, this 9 over 5 is A, and the 2/5 is B. Okay, so that deals with Z. How about W? Well, W is I times Z. Z, we've just calculated this. So I can put this straight in. If I times this out, I get 9 over 5 times I plus 2 over 5 times I times I. And it keeps appearing everywhere, this I squared. I squared is minus 1. So actually the second term is just minus 2/5. And the first term is 9 over 5 times I. So for this case, for the W, A is minus 2/5 and B is the 9/5. So there you go, that's the process for dividing. We need to use the idea of a conjugate, and there's a lot of multiplying going on, and this is absolutely key. I squareds are going to start appearing, so we need to be able to use these ideas to simplify our equations. Okay, so what was part B? Find the modulus of Z. So what does modulus mean? If we take any number, maybe I'll just pick A plus BI. This is a complex number. What's the modulus? Well, it's just the distance from 0 in the Argand diagram. And we just use a bit of Pythagoras. It's A squared plus B squared all rooted. So in our case, W is minus 2/5, as we can see here, plus that 9/5i. So drop that straight in. The modulus of W is this one squared plus this one squared, all square rooted. So I have a calculator here, let's do it. So minus 2/5 all squared plus 9/5 all squared equals 17/5. Square root of that, 1.84, and there's loads of other numbers on the end. For these questions, 2 decimal places should be fine. So 1.84. So there you go, there's the modulus. Part C says find the argument. So now I'm going to draw it, and should get an idea of this number, the modulus, because it's a distance. Let's see it. So for part C, here's my Argand diagram. We have an imaginary axis and a real axis. My W, I'll just write that again because I can't see it on this page. It's this one. So how do we plot this? Well, this is the real part. So if I call this one maybe -1, -2, I and 2i here. So we have roughly here it's minus 2/5, and roughly here is the 9/5. Okay, so we've got our Z, and we know the modulus is the distance from 0. We calculated this already. To part B. For part C, we want the argument. So what does the argument mean? Well, it's the angle from the positive x-axis, the real axis, to the number, and the argument must be between minus pi and pi degrees. So in our case, it's going to be this number here. Okay, so the argument of Z is this angle. Okay, so let's do it. Let's find this angle. Well, I'm going to take a look at this triangle because I know all the pieces. I know across the bottom this is 2/5, and up I know is 9/5. It doesn't matter that the bottom is a negative. I'm just looking at it from just a general point of view. We have some triangle here, and using some basic trigonometry, I can find this angle, and if I know this, I can find phi because it just sits on a straight line. Okay, so tan of phi is the opposite over the adjacent. The opposite is 9/5. The adjacent is 2/5. So straight into the calculator. I'm going to do this in radian mode. So check my calculator. It's not in degree mode. So shift and menu. And now I need to find the angle units, which is rad. So now I can see on my calculator there's a R written at the top. There's no D there anymore. And in my calculator, I'm going to take tan inverse of this number, which is equal to, let's do it, 9/5. I could have simplified that fraction. It's a bit late now. 9/5 divided by 2/5. I make this 1.35, so on and so on. Okay, I worked at 2 decimal places. So from this, well, the angles on a line add up to 180 degrees, or pi radians. So my phi plus my theta is pi, which means the argument theta is pi minus phi. So I'll put straight into my calculator, pi take away 1.35, and I find the argument is 1.789, so on, so on. Let's call that 1.79 radians. Okay, so there's your angle, 1.79 radians. Okay, so the next part of the question was draw Z and W. Well, I've drawn W, so next let's draw Z. Maybe I should use a new picture. Let me see, is it going to get messy? So actually, no, it's not going to get too messy. So I'm going to put on the same picture. So the Z was 9/5 plus 2/5 of I. So 9/5 is just less than 2. So there, roughly. And then the 2/5 of I is right about by here. Okay, so there's my, oh, that's not Z, that's not W, it's Z. Let's correct that. There you go, there's my Z. I'm not going to do anything else with that, just going to show it on a picture. There it is.